Hello guys, welcome to GFG Weekly Coding Contest Series. And in this video, we are going to solve first and second problem of uh, Weekly Coding Contest 147. So the first problem is equality. So the problem statement is you are given two integer a and b. We have to determine if a can be transformed into b through a series of special operation. In each operation, if a is odd, add 1 to it. If a is even, add 2 to it. Check if it's possible to reach B after performing a certain number of this operation. Now we have to return 1 if it's possible, otherwise we have to return 0. Now the problem statement is we will be given two numbers A and B, and by performing some operation on A, we have to reach B. Um, so operation consists of if A is odd, we have to add 1 to it. If A is even, we have to add 2 to it. And if it is possible to reach B, we have to return 1, else we have to return 0. Okay. So, as in this example one, we can see that A is 3, B is 6. So add 1 to A as A is odd, so it will be 4. And then add 2 to A as A is even, it will be 6. Similarly, if A is 8 and B is 9, our output is 0, as we cannot add 1 as A is even. And adding 2, it makes greater than B. So we can never obtain the condition of A equal to B. Now the constraints are, now we can do this code is problem you by using big O of n. But in this case, the constraint are given specific. The constraint are specified as a and b is between 1 to 10 raised to 9. So doing it big of n operation will give a time limit exceeded error. So in this case, what we will have to in this case, it is particularly this problem is particularly specifying that we have to definitely do in big of 1 or big of log n. So proceeding to the explanation. Now, this problem revolves around a mathematical concept, basic mathematical concept of some conditions that if odd is added to odd, we will give an even number. Second, if even is added to even number, we will get an even number. So, using this concept, we will use this concept in this problem and solve this problem. So, the approach is so as I said, the condition if odd is if we have an odd number and we add 1 to it, then we will get an even number. And if we have an even number and we add 2 to it, we will get an even number. So using this, let's take this example of as A is 11. So let's take that. So, so let's take an example specifying or proving this condition. So as you can see, in this example, we have taken a number x11, which is odd. So if we add 1 to it, we will get an even number. And that if we get added even 2 to it, we get an even number. If we add 2 to it, we get an even number. Okay, let's take a second example of 9. So if we add 9 is an odd number. So if we add 1 to it, we will get a 10. So using this condition or using this approach, we will solve our problem. So let's take this example as mentioned in the GFG. So A is 3 and B is 4. So let's take the example as A is 3 and B is 6. So in this case, our A is odd. So as our A is odd, we have to make it even. So we will add 1 to it. So if we add 1 to it, it will be 4. So if it be 4, we have to add 2 to it. So it will be 6. That's how we will reach our answer. So this is a particular hint that we have to perform some condition to so that we will not reach from A to B. We will not perform any other operation. We will just check using some condition that is it possible to reach from A to B. So as you can see, our first operation will so considering A will be of A will be either a odd integer or an even integer. So considering the first condition, if A is odd integer, so if A is odd, means 3 more 2 is not equal to 0, then we have to make sure that B is even. Why B is why we have to make sure that so if A is odd and B is odd, so let's take A as 11 and B as 15. Okay, so in this according to the question, if A is odd, we will add 1 to it. So A plus 11 plus 1, which will make it 12. Now, 12 is an even number. So 12 will never reach to 15 because we will only add 2 to it. Okay. So if A is odd, we have to make sure that B is even. Now the second condition is if A is even. Now if A is even, we will make sure that our B is also even because considering as A as plus 1, so if we get a even number, we will always add 2 to it, and 2 is an even number. So adding an 2 to an even number will always give an even number. It will never give an odd number. So we have to make sure that our B is also uh, even. So that's how we can solve. We will solve this problem using bigger of one uh, time complexity by just following just following some conditions. So this will be a code to this problem. So first we will check if grade A is greater than B. If A is greater than B, then it will never possible to reach A to B because A is greater than B. So we will return 0. Now second condition is if A equals B. If A is equal to B, then we don't have to perform any of the operations. We will return our result as well. Now the sex as I explained in this the second condition is if A mod 2 equals 0. If A is even and our B is even, then we will return 1. And the second condition, if A is odd, then our B is even, and we will return 1. Else, if none of these conditions satisfy, we will return 0. So let's try submitting this problem. So it is on compilation, it is not giving any error. So let's submit the problem. So it is successfully submitted. So the time complexity of the approach is big of 1 and space complexity is big of 1. Now let's forward into our second problem, which is beautiful bits. So this is a very interesting problem which use concept of bits or concept of prefix sum or segment tree. Why I use segment tree? I will explain this in the upcoming time. So the problem statement is we are given an array ARR. You are asked two queries. Now for each query L comma R, you need to find the maximum minimum integer x such that ARR of L and x plus AR of L plus 1 and x plus AR of L plus 2 and x till AR of R and x is maximum. Now we have to find a number x which on AND operation of a certain number gives a maximum result. So as is the input is n is equal to 5. And this is our ARR. These are all our queries which are going to perform on our ARR. So the first query is x equal to 7. So hence it will be 3 and 7. So the query is between 1 and 2. 1 and 2. So it will perform on 3 and 5. So 3 and 7. So in this example, they have taken the minimum value as 7, which will do AND operation on the elements. So 3 and 7 and 5 and 7 will give us 3 plus 5 is 8. And the second query is 2 comma 3, 1, 2, 3, which is 5 and 1. So doing the same operation, 5 and 5 plus 1 and 5 will give us 6. Now, as you can see in this example, it is mentioned it is here mentioned that and add on doing an AND operation, we want 3. So on doing an AND operation of 5 and 7, it is giving us 5. Here you can see that on giving an AND operation between 5 and 5, it is giving a 5. And doing on AND operation 1 and 5, it is giving a 1, which is resulted to 6. So this is a clear indication that we have to choose a minimum value which have bits all set to that element. Means okay, let's take this example. So, first of all, let's decide. Uh, take what is AND operation. So the bits for 3 is 0 1 1 and the bits for 5 is 1 0 1. So on and doing an AND operation, so in on this 3 and 5, it will give us 1 1 1, or and it will give us 1 because in AND operation, if both of the bits are set, it gives a 1 operation. If any of the bits are 0, it will give a 0. Now As you can see in this example, uh, in 3, 2 bits are set, which is 1 and 2. In 5, 2 bits are set, which is 1 and 4. Now, we have to take a certain number which has both of these bits set and which have both of these bits set. So, as you can see, 1, 1. So, we have to take a number which has set bit at 0 or set bit at 1. But here it is 1 set. So, we have to take a number which has set bit at 2. And you can see in the set bit at third position. We have to take a number which is set bit at 4. So, it is considered 4 to 1. So, take, I am explaining using 4 to 1. So, we have to take a set bit which have bit set at third position. Okay, so as you can see that the best minimum value which have all these bits set is 7, which is 1, 1, and 1. So as you can see, the 3 and 7 will give us 0, 1, 1. So this is a scenario that we have to consider, that we have to find a certain minimum value which has all the bits set uh, associated to the bits of that element. Okay, so I think you have got the explanation or got the in got the initiative of why I'm thinking in this way. So how now? What the question is? How we will achieve this number? So as you can see, the 3 and 5, all the bits are set. In 3 and 5, we have to find a number with which are set. So instead of finding a number of bits and setting it and creating an element, what we can do is we can do all operation of 3 and 5. So what OR operation of 3 and 5 will give us? So the OR operation of 3 and 5 will give us 1, 1, 1, which is 7, which we need as a minimum value. Because what OR operation does, OR operation, if a bit is set, irrespective of the another bit, it will give us a 1. So we don't have to iterate over the bits and form a number which have a set bit at a position. So let's take another example of 1, 4, and 3, as it is said in as we have considered 3 and 5, 1, 4, and 3. So for 1, 4, and 3, the set bit is at position third one. The 4 at the set bit at position third, and for 3, the set bit are at position 1 and 2. So our bit will be our minimum value will be all of 1, 4, and 3, which is 1, 1, 1. See, as you can see, 1 is here, 1 is here, and 1. So it will be finally it will be 7. So as you can see, they have used 7 here. So let's take another example also of 5 and 1. You will get a better understanding. So, for 5, the set bits are 401. For 1, the set bits are 001. So doing an OR operation on this will give us 101. So doing an OR operation will give us 101, which is 5. So this is the number that we want, and this is the number that they have used. The number 5 is the minimum number that we can use to do an AND operation, so that we get so ultimately we get the number uh, 5, or ultimately we get the number 1. Okay, so this will be our first step. Now our second step will be to find out the sum of that range, or find out the set bit, or find out the minimum value of that range. Now, to find out the minimum value of that range, there is a data structure called segment tree. So what segment tree does is it will find. Give me. So I will give a small understanding of what segment trees are. So the segment tree, what we take is we will at a leaf node we will have our array elements. So as you can see, 3, 5, 1, 4, and 3. And we could so it the segment tree find us a some between a range in bigger of log n time. So as it traversed the tree, with between a range. So let's take an example. We need to find a range. So the segmented first builds the tree of that particular element. So as you can see that the elements are 3, 5, 1, 4, and 3. So it will build as 3, 5, which is 8. So here is our 8. And then what will be our then upper on the upper side it will is 1, and 8. So it will be 9. And then you can see the 4 and 3, which is give us 7. And then 7 and 9 gives us 16. So segmented builds us a kind of tree-like structure which gives us sum between a particular range. So this will help us to find a minimum value and a range minimum value and the sum of that range. So why we need sum of that range is will be explained in further in detail in this further in this video. So this is this is our build tree. So we will we will use build it function to build our tree. So this is our function which builds our tree. Is take the parameter as 1. So our 1 will be our node, 0 will be our start, and 4 will be our end. So 0 and 4 are particular. So 0 and 4 are this 0, 1, 2, 3, 4. So start and end will be our indices of our array. And our node value will be at 1. So our node value is 1. Consider it is considering that our root node will be at position number 1 in the array. Okay, so to build it builds our tree. So it takes three parameter node start and end. So if node equal to end, then it set the then it so let's take first an over let's take a understanding of our code like what segment tree does. So first of all, we will have an array list of tree. Then why I am using this array list of tree? Because we want to store both elements at a certain index. The first element will be our sum and our second element will be our minimum value. Then int nums, which will be our array. Then int n, which will take the size of the nums. Now on initializing the segment tree, we will pass our array of nums. So then this dot nums equal to num, this dot num equal to nums dot length, and this dot tree equal to array list of 4 into nums of length. So we are uh, creating a tree of size 4 into nums of length. So our nums of length is 5. It will make an array list of size 20. Now why we are considering this 4 into nums of length? Because in total we have 2, 3, 4, 5. In total we have 5 elements. So as you can see, the array which will hold this tree will consist of 1, 2, 3, 4, 5, 6, 7, 8, 9. Will consist of 9. Uh, will consist of 9. So it is an upper case where we are finding the where we are taking 4 because let's take an example of 4. So 4 is a multiple of 2. So it will take at most it will take 4 into 4 into nums of length. At most it will take 4 into nums of length. Because this upper bound means it will test to all the elements. There will be certain position which will be empty. So this will be our array of tree as you can see, and these are our element which stores the 16. So one is considered a root node. As you can see, it stores 16 comma 7. 2 stores 9 comma 7. 3 stores 7 comma 7. Then there's 4 goes to 8 comma 7. Then at the you can go through this, and our last to the code to for building the tree. So as you can see, if our start equal to start, we will just set our we will set our tree at by the given node. So at index node, we will set our nums of start, comma nums of start. Now, why nums of start and comma nums of start? This will be our sum of that particular node. Now, consider this tree. because we have stored some S3 and a minimum value S3, because for 3 we will take a minimum value S3, because it won't be necessary with any other value, because 3 and 3 will always give us 3, hence we have set 3 comma 3. Now if start is not equal to end, it will be, so we will do a mid operation, start plus and divided by 2, and we will call two recursive function of 2 into node. So 2 into node will give us a node of that right child, and 2 into node plus 1 will give position of is, sorry, so 2 into node will give us a position of left child, and 2 into node plus 1 will position of right child. So so let's consider 1. So for 1, the 2 into node, which is 2. So it's left child is 9 comma 7. So as you can see, 2 9 comma 7, and 2 into 1 plus 1, which is 3. So as you can see that 7 comma 7, here 3 has 7 comma 7. So finally left and right child we are calling 2 into node to node plus 1. And the second thing, we will pass our start and mid, as we are building a tree from start to mid, and then we will build a tree from mid plus 1 to end. Now, after both of the function call are done, what we will do is we will have a sum variable which takes its left child 0 position, left child right child 0 position, to get the sum of left and right node, left and right subtree. And will minimum value will have a OR operation. So the OR operation is a minimum value which is for the left subtree and right subtree. And then we will set our node with the sum and minimum value. So that's how we will build our tree. And then after that, the next step, we will do a query operation on it. Now, on a query operation, let's take an example of 3 and 4. So let's take an example. So our node value is 1, because 1 is at our root node. Then start will be our 0 and end will be our 4, because these are the indices of the array. Now, our left and right are queries. So 3 comma 4 is this one. So our left and right are queries. So 3 comma 4 are 3 comma 4 are certain numbers that I have taken. So 3 comma 4 are the query, so one of the query. So so this condition will satisfy if left and our our range 3 comma 4 is does not uh, no overlap. This condition satisfies no overlap. So if our so let's consider, so if our right is 3, so is 3 lesser than 0? No. So the second condition it will be check is left. So our left is 3. So is 3 greater than and is 3 greater than 4? No. So this condition satisfies no overlaps, and it will not be satisfied. It will go to else condition. Now our else condition satisfied uh, overlap, full overlap. So the full overlap, what we will check, left 3 is 3 lesser than equal to 0? No. No, 3 is not lesser than equal to 0, then it will go to else condition. Now at else condition, it will do a mid operation, and we will call two function, or 2 into node to go is left child, and 2 node plus 1 to go to is right child. And in the first function we pass start mid left right, and the second function we call for mid plus 1 uh, and left and right. And both of the by getting result from both of the array, we will do a sum of left of sum plus right of sum, and we will find out the mean value of left of sum or right of sum. So as you can see that 3 and 4. So what is 3 or 4? 4, 5, 6, 7. So, so as you can see that our start and ends are 0 and 4. So 0 and 4 will be from 4. So doing a mid operation, and it will give us 2. So our first function call will be 0, 2, left, right. So let's consider the uh, second operation as 1. It will go to 2 comma, our start will be 0, our mid will be 2, and our query is 3 comma 4. So as you can see that 3, so our first condition is if is it satisfied or not. So is 3 lesser than, sorry, is 4, right, is our right is 4. So is our 4 is lesser than 0? No, our 4 is not lesser than 0. So it will go to a second condition. Is our 3 greater than 2? Yes, our 3 is greater than 2. Means this condition is satisfied, means the one, it has no overlap because our 3 is greater than n, means it is after the range 3 comma 4 is after our n. So it will be satisfied and will return 0 0. In the second condition, it will call to node plus 1, which is 3, and it will call mid plus 1, which will be our 3. Then our end is 4, and our left and right are 3 and 4. Yeah. If we go to the first condition, so is our right, which is 4 lesser than 3? No, 4 is not less than 3. Or our 3 is 3 greater than 4? No, our 3 is not greater than 4. Then we go to the second condition. This is our second condition. For the second condition, it will check is our left 3 is lesser than or equal to start, which is 3. Yes, it is satisfied. Second condition is 4. Is 4 greater than or equal to 4? Yes, it is satisfied. This means that the range 3 comma 4 is fully overlaps between the range start and end. So hence we will return our tree dot get of node. So our node is 3, so it will return. So what is stored at 3? 7 comma 7. And what we are getting from, so this will return as, let me write it. This will return 0 comma 0, and this will return 7 comma 7. Okay. Yeah. So our sum will be as 7 left, and our min value will be 7 or 7, which is 7, and hence we will return 0 comma 7. So for 3 comma 4, we are returning 0 comma 7 to our call function, this to our query. So this will be our provided result. We will take the second parameter of our result, which is 7. And as we need to find the minimum value. So let's check if 7 is correct or not. So 3 and 4, between 3 and 4, between 3 and 4, it is, so for our 4 is, our 3 is, so this is our third and this is our fourth position. So if 4 and 7 gives us 4, and 3 and 7 gives us 4. So we will get an 8, and our minimum value will be 7. So we will get our sum as 7, and our minimum value will be 7, and hence we are getting the correct answer as 7 comma 7. So this will be building a tree and querying on the tree to find out the minimum value that we need to do an AND operation to get a maximum sum. So let's go to our code. So, uh, so we are initializing a segment tree which we are passing an ARR. So as I've shown previously, this thing initializes all our required parameter that we need, and then we are building our tree. And this code builds our tree, as you can see. Then I have taken this initialize array because the array list is initialized that we can pass an input parameter 4 into nums of length over array list, but the size will be stored internally. We have so on inputting parameter on getting value at a certain position, it will give an error. So hence I have called this function, and uh, I have initialized every node. I have initialized 0 comma 0 till 4 comma n, 4 until 4 into n. So we will have our related tree with at every position from, we will have our tree from 1 to 20, but it will under every position we will have a 0 comma 0. Now we will iterate over queries and st.range function. In this we will pass our queries minus 1 and queries I0 minus 1, queries I1 minus 1. So the range will call query, and in the query we are passing 1, which the 1 is a root of our tree. The 0 comma n minus 1 is start and end of our array, and left and right are the queries that we need to perform. So this is the query function which This is a query function that we need to iterate to find out the minimum value and the sum. After getting the result, we will store a answer of 1 in our result array, and then we will pass our result. So the time complexity of this approach is big of n, as we are building a tree. Hence, it will big of n because this build function uh, iterates over every element of the array just once, and to store and to find out the minimum value and the sum, it is just taking big of one as operation, big of one operations. And the time complexity of this approach is bigger of n, and space complexity of the approach is bigger of n. Because for space complexity is, we can consider space complexity as 4 into n, but 4 into n is a 4 is a constant, so we will make it to bigger of n. So is there anything left? This operation is doing in bigger of, and the okay, the query to find the query is doing in big of log n. So as you can see, we are iterating over the queries, and we are finding a minimum value between a range. So the range took big of log n time to find out the minimum value. So big of log n because uh, it is going over the node in a in the tree in this fashion. The for first, second is third, and fourth. So in this whole tree, it will just take big of four operation. So it will be big of four operation, one, two, three, and four. So because it is taking big of log n time. So the query is taking we are iterating over the query's length, which is of length m, and we are finding a query, we're finding a range, minimum value between a range, it take big of n log n time. So the time complexity of this is big of n log n, and the space complexity of this approach is big of n. So this will be it for this video. I will cover the second and third problem in our next video. So stay tuned for another video. Bye.